Hello everyone, welcome back to my class. Today I will teach you differentiation or derivative for class 11. So for doing derivative, we have to know the what is derivative. So for that we have to know the increment also. First we discuss the definition of derivative, then we'll discuss the increment portions. Okay. So what is derivative? So derivative means the rate at which dependent variable changes with respect to independent variable. So what you can say that the rate of changes of dependent variable with respect to the independent variable, that is called derivative or differential coefficient. Or you can say that when the rate of changes is measured by a quantity, that is known as derivative or differential coefficient. Means differentiation deals with the changing of rate of dependent variables. So when you measure it by a quantity, that is called derivative or differential coefficient. Okay. Suppose this is a function y for fx. So you can say that for the value of x, this y will change. Means if you will take x is 1, so y will get something that will dependent of x. So this is your dependent variable and this is your independent variable. Suppose your fx is x square. So for x1 you will get y1. For x equal to 2 you will get y is equal to 4. Means if you will put the value of x over here, you will get value of y is 4. So this is your independent variable because you are choosing the value of x arbitrarily. Depending upon the value of x, you will get the value of y. So this is your dependent variable. So when the values or it will be changes and it will be measured with respect to the independent variable, that is called the differentiation. So this is the definition of differentiation. Suppose the value of x0, this is your real value. Suppose the value of x0 is equal to 1. So this is called the initial value. And x1 is equal to 1.02. This is your final value. Okay, this is your initial value and this is your final value. So when you are finding out the difference of it from x1, x0, that means final value minus initial value, that is the increment. So how much increment have been done over here? The value of the increment over here is equal to 1.02 minus 1, that is 0.02. So this is the increment of the value for the variable x. So this is the definition of increment. Okay. Suppose, so how this will express? So this is one example for it. So now we have solved this sum. Now how we will express the increment of function? Okay, how we'll express the increment of function? This is one example. So what is the notation? What will be the notation? The notation will be in this way. Suppose the value for the value, this is the function y is equal to fx. This is the function. Okay, and x is the initial value. Okay, x is the initial value. Now we can say that changes is minor. Okay, minor. That will be denoted as del x. This is the increment or changes the initial value. Okay, this is the initial value, changes initial value. So now what will be the increment value? The value after increment will be x plus del x. This is the increment value. Okay, this is the increment value. So you can say that this is the value for the value x. Okay, this is the increment. Now then the final value for corresponding y will be, so for value x the y is, for value x the value of this function is y. Now for value x plus del x the value will be y plus del y. So changes will be happened on the this function also. Hope it is clear to you. Now what is the increment value for the y? So value for y will be del y is equal to y plus del y minus y. So this is the increment value for the dependent variable. This is the increment value for the dependent variable. Now if we will find the rate of this, you will get the differentiation. So what you will get? You will get differentiation. This increment is for the value of x. So when you are taking this value in the function, this is the initial value of the function y and this is the final value for the dependent variable y. Now this is the changes for dependent variable. Dependent variable. Okay, now if you take the find out the rate of it, you will get the differentiation. This is the increment of a function. Okay, previous one that will be the increment of value. This is the increment of value and this is increment of function. Hope it is clear to you. Now what is the definition of it? Definition of derivative or differentiation. So from here, when you are taking the rate of it, that means with the limit. So this is the changes, and how much changes will be have been happened, that will be considered by taking the limit on it. So derivative, what will be a derivative? Abbreviation of derivative, that will be the derivative of the function y is equal to fx with respect to x at the point x is, this will be taking with the limit. Okay, this is the this will be taken with the limit. Okay, so what you will get? Limit del x tends to 0, del y by del x. Okay, taking the limiting value of it. So your del y, what we have found, that is f x plus del x minus fx, because in previously we have found del y is equal to y plus del y minus y. So it can be written as f of x plus del x minus fx. Is it or not? We have already found it. So we have putting the expression this expression in this way. Okay, so in lower part or in denominator it will be del x. Now this del x will be replaced by one value h. So h tends to 0. F of x plus h minus fx by h. So this is the principal definition, or you can say that principal abbreviation of derivative, and it will be written as dy dx is equal to, okay, dy dx means changes of this variable y with respect to the independent variable x. Hope it is clear to all. If you having any doubt, please ping in the comment box. I will solve it. I will explain it more. Today's class is up to this only. In next day, we'll do the application and do the rest of the portion of the derivative. Okay? Today's class is up to this only. Goodbye.